Pseudo multivariate calculus. Pseudo multivariate calculus, unprecedented. Okay, this is something that is coming from us only. There is no book, there is no publication, there is nothing in the internet. You can find a concept like pseudo multivariate calculus. Can we write whatever we want in terms of simple mathematics, and then we can start doing the calculus? People generally they find highly difficult to mold something, model something, any problem into calculus. Okay, I know this is the problem, but how I can use calculus, where I have to use differentiation, where I have to use integration, that I don't know. How I have to put dx, and in multivariable case someone needs to put dx, dy, dz, and so many multivariable independent components are more than one. Then why it is called multivariable calculus? So it is extremely difficult. Someone is getting electronics problem, someone is getting electrical problem, okay, someone is getting capacitor resistance and this kind of problem. All of sudden, how I can tackle it through calculus? If I am not using calculus, then what mistake I am making? If I am using calculus, then why I am going through unnecessary difficulty, unnecessary complexity? Okay, pseudo multivariate calculus. Can I write a simple mathematical formula and then I can proceed upon without knowing that it is actually calculus, pseudo multivariable calculus? Anyway, in that sense, we are taking help of vector notation. So vector, algebra, calculus, all are coming into the picture, and we have divided it into many areas. One is called length vector, one is called area vector, one is called volume vector, one is called weight vector. The way the number of multivariable independent variables are growing, the way we are growing. The simplest one is length vector. Length vector. Length vector, what we have found length vector is how to find. Okay, so length vector in the sense that if I have a line, if I have a line, then how I can find length of this line? What is the equation of the line? Consider the equation of the line is y equal to x. Okay, so y equal to x is the equation of line. Now, this is y equal to x. This is x-axis and this is y-axis. This is origin. This is this is y equal to x. Can someone find along this line? Can someone find the distance between origin and any point x comma y? Now this is called, I am trying to find the length of this line from 0 comma 0 to x comma y. In that sense, I have to find the vector representation of this line, and that representation can be achieved with any 2 points. One point is 0 comma 0, another point is x comma y. In that sense, vector representation is xi plus yj. Just calculate the magnitude of the vector, you get the length of the line from 0 comma 0 to x comma y. Okay, this is called length vector. This is called length vector. Xi plus yj is called length vector. Okay, more complex is, consider instead of a straight line, consider there is a curve. If there is a curve, then what is the length of this curve from origin to any point x comma y? In that sense, again I have to go with the same fundamental to represent this curve through a vector, and then magnitude of the vector will give the length of this curve. Now, if I take x comma y and then take a vector from here directly from origin connecting x comma y here, then this vector is again xi plus yj, and it will give the length of the straight line, not the curve. Okay, then we found that what is difference between a straight line and a curved line. Straight line, if I see, if this is x-axis, then a straight line, everywhere y by x is a number. Y by x is a number and it is a constant. If it is 4, then everywhere y by 4 is 4. Y by x is 4. Whereas if it is a non-straight line, then everywhere y by x will not be the same. Like I gave example, like consider that a kind of this, okay, okay, let's go with the old one only. X square. Y equal to x square. When x is 10, y is 100. When x is 4, y is 16. Here it is 4. Here y by x is 10. Everywhere y by x is different. So if I am going through a generic concept to find the length of a curve, then we say begin point and end point, represent it as a vector, and then calculate the length of the vector, you get the length. Now vector form is xi plus yj. I can take out x and it becomes I plus y by xj. Y by x is different. Y by x is not constant for the curve. So it becomes I plus y by xj in bracket close into x. Now this form would tackle the curve also because it has y by x that is variable everywhere. So I plus y by xj into x. Now this is the representation of vector where it covers the variable part y by x. Now this is y by x. Now when y is dependent upon x and it is a division, I can change it into dy by dx. Okay, and this vector I plus dy by dxj, this vector is dependent upon there are two items. One is called division and one is multiplication. Division is y by x, where multiplication is I plus y by xj bracket close into x. So multiplication, the right hand side of the multiplication, the operand of the multiplication is independent component x, whereas this side is a dependent full I plus dy by dxj full. It will come in form of x only. This full is dependent upon x. So I can turn it. This is something like fx x, fx into x. Now, if it comes in fx into x, then it is integral calculus. If it is come in the form of fx by x, numerator is dependent upon denominator, then it will come as differentiation. So it becomes I plus dy by dxj bracket close into dx. Now x is from one point to another point for which we are trying to calculate the length. If I am trying to calculate the length of this line from origin to a point here, that is x comma y, interception on x axis is x. Then we are trying to calculate this length, x is 0 to x. Now integration from 0 to x, I plus dy by dxj dx. This is called length vector. I plus dy by dxj into dx is called length vector. I can multiply this. This is our invention. This is not available in any of the book. We are not reiterating that is written in the book. Whatever we are saying, that is not available in the book. Okay, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Anyway, now in this scenario, what is your length vector? Length vector is I plus dy by dxj in a bracket into dx. This is my length vector. What you want? I want energy calculation. Energy calculation is force into displacement. Force vector dot displacement vector. This looks very good if displacement vector is a straight line. Okay, force vector can be anything. Dot displacement vector. Force in the direction of displacement multiplication is the net energy, net work done. Now consider there is a earth gravitational pull. I believe this example I gave last time. It is an assignment, I believe. Can someone calculate? Okay, so down the line there is a earth. So down the line there is earth. That is earth, and this is a ball. If I just leave this ball, then it drops. It doesn't drop. Earth pulls it. Earth is working on it. Earth is releasing energy on it. How much is the earth releasing its energy when this item, this point is x comma y? This item is going and hitting the surface that is 0 comma 0. From x comma y to 0 comma 0, if this earth is losing energy making this ball move, that is the better word. Earth is losing energy in order to make this ball move. Ball is not moving for free. There is energy involved in it. There is earth gravitational pull forces are like this that are invisible. We are not able to see it. There are force. If someone is hitting me like this, then I can see that okay, there is a force on my face. But generally we feel relaxed. It is nothing is there, but earth gravitational force is all along. If I just leave it, it comes in earth gravitational force and earth starts working. Means earth start releasing. If everyone start doing like this, then earth will become energyless because a lot of energy it is losing in that fashion. So how much earth is losing energy when item is moving from this point in x comma y to origin? That is the concept. Okay, or consider consider this is x-axis. This is x-axis and this is the curve. Equation of the curve is x square. Now consider this is 100 meter. From here to here it is 100 meter. Then this height is 10 kilometer. This is 100 meter. This height is 10 kilometer. This point is 100 comma 10 10,000. Or this if this is x, then this is x comma y, where y is x square. Okay, if that is the case, then consider that I have made a hole in this and I pierce this inside this. Now, if I just leave it, this will fall like this. Consider this point is origin and this point is x comma y. Now from 10 kilometer height or x comma y, if I leave this ball, it will start along this curve, it will start moving like this and at the origin it will come. How much earth is losing energy when this item is moving in a path from a point x comma y to origin? That is the question. Okay, then it is force into displacement is the work done. Okay, I don't know about vector, whatever it is. Force into displacement is the work done. Force into the length is the work done. What is the force? Gravitational force of the earth is gmm. G is gravitational constant. M is mass of the earth. M is mass of this. Gmm r vector divided by r to the power 3. Okay, in that sense, Gm, G gravitational pull, gravitational pull, G into M, mass of the earth, M, mass of the entity, divided by r to the power 3 into r vector. I can take out Gmm because these are constant. Now I have r vector divided by r to the power 3. This is earth gravitational force. Okay, multiplied by the this is the invention. If someone wants to multiply anything with a distance, then multiply it with the length vector. What is your length vector? That is I plus dy by dx j bracket close dx. I need to multiply the earth gravitational force with the length vector to calculate the net energy that is involved in making item move from one point to one point. Ask anyone that there is a earth gravitational pull and one item is moving from point x comma y in a path that is y equal to x square. How much energy the earth is liberating when it is moving from point x comma y to point 0 comma 0? Ask anyone. Now he will start sweating. Now force into displacement is the energy. Force is earth gravitational pull. Now it is going toward the earth. It is in it is in a spherical coordinate system gmmr vector divided by r to the power 3. Okay, whereas I have this in Cartesian coordinate system, this line equation is y equal to x square. How I can multiply these two? Not possible. Okay, there is something called that whatever you are thinking, make things in the highest degree. Highest degree in mathematics is vector. Numeric science, algebra, calculus, and vector. So vector is a, let's bring everything in vector. So anyway, now let's change this earth spherical coordinate system force into Cartesian coordinate system. Then G M M R vector will become xi plus yj plus zk, because that is the Cartesian coordinate system. That is the spherical to Cartesian coordinate system. If I have a sphere, okay, I really have a very different kind of a sphere. Okay, this is this is my sphere. If this is my sphere, consider this is centered at the origin, and then from center, if I take any point here, a vector will go, and that is the r vector. Now, if I talk about r vector in Cartesian coordinate system, then think that when center of this, I am drawing a straight line and it is passing through a point called x comma y comma z. This r vector can be represented as xi plus yj plus zk. So earth gravitational pull is gmmr vector divided by r to the power 3. gmmxi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Okay, this is vector notation. Dot product. Dot product this with the length vector. Whatever the vector we have calculated, length vector. Length vector is I plus dy by dxj bracket close into dx. Do the dot product now. Okay, that is the concept. Now, here is that we are taking height. We are taking height as z-axis, this as x-axis, this as y-axis. Now, if I am talking about the length vector, if I am talking about the length vector, if I am talking about the length vector, then this is z-axis, this is x-axis, this is y-axis. In that sense, our formula will change into I plus dz by dx, not dy by dx, because z is now vertical now. I plus dz by dxk into dx. Now here we have gmmxi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. If someone does this dot product of these two, j component will go away and I and k will remain there. gmm is the constant. I can keep outside permanently, gmm. Now we have x by x square plus y square plus z square to the power 3 by 2, 3 by 2, I dot product gone. And we have dx outside, x dx by x square plus y square plus z square to the power 3 by 2. Plus we have this side z and that side dz by dx. So we have z dz by dx k k by k gone, z dz by dx by x square plus y square plus z square to the power 3 by 2 into dx. The length vector is I plus dz by dxk bracket close into dx. Now this dot product with the gmmxi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. We are trying to make energy calculation force into displacement. Displacement, we have termed it into length vector, area vector, volume vector, density, weight vector. This is what we will see. This is the invention. Means it's a pseudo code, right? What is the energy involved? That is work done. What is work done? Force into displacement. What is your force? Force is gmm xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Dot product with the length vector. Okay, means displacement is length vector. That is I plus dy by d, I plus dz by dxk dx. Simple. No need to think where, because I had talked about a line that is y equal to x square. Through that the displacement is happening. Make it into a vector form. Now it came as gmm x dx divided by x square plus y square plus z square to the power 3 by 2 plus gmm z dz by dx divided by x square plus y square plus z square to the power 3 by 2 into dx. What is dz by dx? Okay, what is dz by dx? Now, if we see, because we are trying to find things along this line. Now, here z equal to x square. dz by dx is 2x. Okay, now z into dz by dx, x square into 2x divided by x square plus y square plus z square to the power 3 by 2. Okay, x square into 2x is 3x, 2x to the power 3, and then dx will come outside. Now full become gmm x dx, x dx, and here 3x to the power 3 dx. All will become now x plus 2x to the power 3, x plus 2x to the power 3 by x square plus y square plus z square to the power 3 by 2 dx. Gmm is outside. Now x is from whatever, if I'm saying this is origin and this is x, then x is from x to origin. It will be negative and it will come as positive because actual equation of the force is minus gmm r vector divided by r to the power 3. So net it will come positive only, and it is positive because earth is liberating energy. Okay, so net energy calculation is gmm x plus 2x to the power 3 in bracket divided by x square plus y square plus z square to the power 3 by 2 dx. That is x to 0. Now someone can calculate this is the energy, and it looks like very difficult. Anyway, now what we can do here is we will take different earth gravitational force. Earth gravitational force right now it is very complex. So let's take Earth gravitational force at xi plus yj. Earth gravitational force is xi plus yj. Now it is simple. Okay, xi plus yj. Now if it is xi plus yj, then what is xi plus yj dot product with the now consider that this is y axis and this is x axis. Z axis, forget it, because we are talking about a line only. Consider this case. Okay, I don't want to go into z now. Consider that this is y. Right now consider this is y and this is x. Everything is happening in yx plane, and that is vertical now. Consider the earth gravitational pull is xi plus yj. Now it is xi, earth gravitational force. Now it is xi plus yj dot product with I plus dy by dxj bracket close dx. That is length vector. Okay, if that is the case, then it will come as x dx and y into dy by dx. Y is x square and dy by dx is 2x. 2x to the power 3 dx. Now full will come as x plus 2x to the power 3 dx. Now it will become x square by 2 plus x to the power 4 by 2. That is the net energy calculation from point any from point one point, that is x, to 0. Now if I'm calculating consider this is 2. Consider this is 2, then it is 4. Anyway, we are trying from 2, 0 to 2, 2 to 0. From here it is falling here, or 0 to 2. Make it positive only. 0 to 2. In that case, 0 to 2, then 2 will become 2 square by 2, that is 2, and 2 to the power 4 by 2, that is 8. 8 plus 2, 10 is the picture. Okay, now people would say energy calculation, the way you are saying, it looks like completely error. Why it is error? Because Earth gravitational pull is path independent. Okay, so either either this ball is coming in x square fashion to here, or from here ball is falling directly from here to here. This point has height from earth is here, and this point of height earth from here to here. If any ball falls from one point to another point, and it takes different path, if ball is falling from here to here, okay, now this point and this point, just take it. Now here to here, it may fall in a circular fashion. Okay, but begin point and end point is same. Or it may fall like in x square fashion. It can fall in a staircase. It can fall in a straight line. Whatever it is. If begin point and end point are same, then Earth will lose same energy irrespective of the path. This is called path independent. Then why you brought y equal to x square terminology? Unknowingly, you are doing error. Means x dx plus y is x square 2x into dx. What about if it is not a curve, it is a circle, then y equal to square root of a square minus x square. Completely it will change, right? Okay, consider that earth gravitational pull is xi plus yj, and length vector is I plus dy by dx j into dx, where y is square root of a square minus x square. It is a circular path. In that case, dy by dx is minus x by square root of a square minus x square. Length vector will become I plus minus x by square root of a square minus x square j, and pull into dx multiplied with xi plus yj, that is the force. Then it will become x dx minus x dx by square root of a square minus x square. This is completely different than x dx plus 2x to the power 3 dx. Result will be different, but result should be same when begin point and end point are same. Either you bring in a circle, bring in a straight line. If I am saying begin point is here, that is 2 comma 4, and end point is origin, I bring it through a straight line. I bring through y equal to x square, I bring through circle. The net calculation should be same. There is something called potential function. If there is a force vector dot displacement vector or length vector, and this result comes as a algebraic value, that is called gx. Gx is a integration of force vector and length vector. It will come as vector independent algebraic function, and if d, that is a result of this xi plus yj dot product with the length vector, if this integration comes in algebra form, and that algebra is gx. If dg by dgx by dx, I'm sorry, the net result comes as dgxy in term of x comma y, in term of x comma y. If dg by dx, dgxy or dg by dx is f1, dg by g2, dg by dy is f2. What is f1, f2? If there is a force field and it has x component and y component, like I'm taking force field as xi plus yj, it has f1 as x and f2 as y. Force field capital F can be written as f1i plus f2j. It has x component as f1 and y component as f2. I'm not saying y, xi plus yj. In Earth, gravitational force gmm, xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. The force field has three components, F1i plus F2j plus F3k. F1 is gmmx by x square plus y square plus z square to the power 3 by 2. Okay, F2 is y, gmmy by x square plus y square plus z square to the power 3 by 2. F3 is gmmz by x square plus y square plus z square to the power 3 by 2. F1, F2, F3. Now this integration, now in this example we have F1 and F2. Force is xi plus yj. X component, it can be yi plus xj. Yi plus xj. Then F1 is y and F2 is x. What is the I? X component means along with I vector, what is the part, that is F1. Along the j vector, j unit vector, what is the part, that is F2. Now, if I am doing the line integration, the energy calculation of force vector dot length vector, this integration comes as a algebraic function g. Then if dg by dx is f1 and dg by dy is f2, then result is only dependent upon the force field, not on the path, that is the length vector. In that sense, it is called path independent, and it is true for the earth gravitational force in reality also. GMM R unit vector divided by R square is earth gravitational pull, or GMM R vector divided by R to the power 3, whatever it is. Consider the earth gravitational pull is GMM R unit vector by R square. Okay, now if for this the potential, consider there is a potential function called GMM by R. Gmm by r. Now calculate the differentiation of this. Gmm by r, it will become minus g by r, means r to the power minus 1. Differentiation will be minus 1 by r square. Okay, so its potential function will be minus gmm by r. For gmm by r square, the potential function, consider there is a potential function already available, that is gmm by r. Okay, gmm by r. Gmm is constant by r. Now, if I calculate the differentiation of this, it will become minus gmm by r square, same as the earth gravitational force. Earth gravitational force is negative actually, that is minus gmm r unit vector by r square. Let's try in the Cartesian coordinate system. Consider there is a potential function that is gmm by x square plus y square plus z square to the power 1 by 2, that is gxyz. What is dg by dx? Just dg by dx. Then dg by dx is g minus gmmx by x square plus y square plus z square to power 3 by 2. What is dg by dy? Minus gmmy divided by x square plus y square plus z square to the power 3 by 2. What is dz by dz? Same z by whatever it is. If I put into a vector form, that is dg by dxi plus dz by dyj plus dg by dzk, then it will be the earth gravitational pull. Means there is a algebraic equation available in the market for which the partial derivative is the earth gravitational pull. In that case, earth gravitational pull is path independent. The what nonsense you are talking, that the energy calculation for the earth gravitational pull is force into length vector, and length vector is different for different kind of shapes. Okay, if it is y equal to x square, the length vector is I plus dy by dx, means 2x, I plus 2xj dx. Length vector, if it is a circular, then I plus minus x by square root of a square minus x square j into dx. If it is a straight line, that is y equal to x, then I plus dy by dx is 1. I plus j and then dx. For every shape, your length vector is different. If I do dot product of that different length vector with the force vector, End result will be different, but end result should be same when begin point and end point is same, irrespective of the distance, irrespective of the your length vector. There where error you are making, we are not making any error. Okay, now consider this for assignment, that how this energy calculation, if I am trying to calculate energy from any point, consider this point is 2 comma 4. If it is on x square, then if this is 2, then this is 4. Consider in the earth gravitational pull, and that pull is xi plus yj. Now it is simple, xi plus yj. If I calculate the energy calculation when point is 2 comma 4 to 0, either it is a straight line or it is a circular line, it is this line, parabolic line, whatever, the energy calculation through our formula is force vector dot length vector, irrespective of anything. So force vector dot length vector will give the net energy calculation. And length vector is different for different kind of shapes, because dy by dx is different. In that sense, can someone prove this? I mean, this is assignment. Someone should try to prove it, that indeed the energy calculation is same from point 2 comma 4 to 0 comma 0, even with the length vector I plus dy by dx j into dx. For different shape, either it is a straight line connecting 2 comma 4 to origin, or it is connected 2 comma 4 to origin, one straight line can connect. Okay, or it is connected through a curve, that is y equal to x square, or it is connected through a circular line, that is x square plus y square equal to a square. Still, force vector dot length vector from 0 comma 0 to 2 comma 4, or 2 comma 4 to 0 comma 0 will be exactly same. Can someone prove it? That is the assignment. Okay, do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Okay, mind blowing, amazing calculus.